All right, Hacksters, what is up? Welcome to Wednesday. It's very What the Wednesday right now. I've been playing around with this device all day, the M5Stick-C, given to me by our friend Mohib Zara. And this is a little ESP32-based device. We've actually covered it before. I did an unboxing/intro a while ago, which you can find on our YouTube channel. It is linked, as usual, in the description to this video. I think it's the first link there. But this is the first time I've actually tried to get it up and running, and it's been a little bit of, it actually hasn't been that bad. So we don't have the cool wrist strap here, but we'll come back later to options that you have for mounting it to stuff. Oh, there's so much interesting stuff going on with this thing. It's packed with sensors. It's got, as I said, an ESP32 for programming it, and it has Wi-Fi access. You've got a built-in 6-axis IMU motion sensor. You've got a red LED, an infrared transmitter, so you can use it to, for example, use it as a remote for your TV or something. You can make a TV be gone with it if you wanted. It's got a microphone, which we'll come back to as well. It's got 2 user-programmable buttons. It's got a small TFT screen, an LCD. You know, I'm a little unclear on that whole thing. Built-in LiPo battery, so it charges through USB. It's got a USB-C connector and an extendable socket. So it's got these 8 little, let me show you, 8 little broken out header pins here. Cool. Or a header socket with 8 pins. What else have we got? We've got, oh, it says wearable and wall mounted. I think that that's what this magnet is that we'll come back to. And then you can develop on it in UIFlow, MicroPython, or Arduino. All those make me really happy, especially MicroPython and Arduino. So Arduino has, a ton of resources out there already, a huge community and stuff. MicroPython is sort of the cool new kid on the block where ordinarily it's very easy to save your code to the device directly, so you don't have to go hunting around on your computer for the right file if you just want to make a small change, and then you just resave it and you're done. It's good. You can read more about this, and it's only $10. That's ludicrous. You guys should be charging more for this. It's really cool. And it's got this really interesting aesthetic where the back of it is just covered in these stickers, as you can see on the website. It's sort of self-documented in that way. Each of the pins is labeled really clearly. You've got color coding. Also indications for whether it's 5 volts in or out. Oh yeah, there's a seed grove connector on the bottom. That's what you can see there. Here as well for I2C. Let me show you that right there. Yeah. You can see it's still going because of the battery, but I'm going to leave this plugged in because, yeah. What else have we got? Oh yeah, so you've got all the certification information, the fact that it's an ESP32 Pico chip. It tells you which buttons which pins the buttons are on, which pin the infrared transmitter is on, which pin the red LED is on, and the specifications and the model number of the LCD, the model number of the microphone, and what pin it's on. This thing is just, it's beautiful. It says all the information right on there. I love it. So it's a really friendly device. It seems to have a lot of stuff that I want and not a lot of stuff that I don't want in a small form factor, which is great. Speaking of which, if you don't have the watch mount, you can create your own. You can also look up 3D printable accessories for it on Thingiverse. There's already a cool looking M5Stick case by Cosmic Mac up here. I would like to print one of those, make it a pendant. Although I might design my own version of this. I think the tricky part is that there's only these very small, tiny slots in the sides to insert prongs into in order to hold it in place. So, the rigid, thin plastic of the original bracket might be best, but we can always try to make our own. There's other cool stuff. For example, I noticed there's this frame and key top for the card KB hat. This is a thing that you plug the M5Stick-C into this with the 8 pins and stuff, and it breaks it onto a keyboard. This is actually something that you can just buy from M5Stack.com. That's so cool. It's got all these little clicky buttons. I kind of really want one, actually. It's an I2C interface. Really pretty. It's run by an Atmega 328P, the same as a fancy Arduino chip. I guess they're not that fancy anymore. You've got Arduinos with like all kinds of stuff, but yeah. A little screw hole to mount it on, and then you can print this thing yourself to sort of hold it in place that beautifully encircles the logo. Oh, so much style in this community. And then, okay, yeah, so I mentioned that you could program it with a bunch of different languages: UI, Flow, MicroPython, Arduino. So I'm going to be using the Arduino library because I'm really familiar with it and it's got a huge following, etc. But also specifically because I wanted to use a pulse sensor with it. I've been having various adventures with that, and we'll see how it goes in the future. But we're going to get to that later on. For now, I've actually published a First Steps with M5Stick-C tutorial. It's just a really quick getting started guide based on what I've done today, which is getting the thing to talk to my Mac and getting the first couple of sketches run. So nothing too complex here, just that I ran into a couple of things that could be annoying hurdles if you haven't done a lot with Arduino, and I've sort of gotten over those first couple humps for you so that it's a lot easier to get started. Oh yeah. So I explained actually the project that I was trying to build today, which is combining the pulse sensor with the M5Stick-C, and that's going to be something for a later day. We'll see if we can get it to work. For now, I've got it hooked up to a microbit. But yeah, it's relatively easy. So the M5Stick-C is included in the ESP32 boards in the boards manager in Arduino. So that's pretty easy. I've got screenshots here of like, where it shows up in the list. You've got the ESP32 Arduino set of boards, and it's just way down here under M5Stick-C. As well as where to find the M5Stick library in the library manager. That's also really simple. You just search for M5Stick and it's right there. This, the main thing for me getting over was trying to figure out how to get my computer to recognize it, because for whatever reason, Arduino didn't want to see it. And usually, it got this timeout message that it was timing out, waiting for the packet header. And that's just a sort of little communication problem. So I looked it up and I had to like go and find a cached version of an old forum post with information about how to troubleshoot that, but it worked. So I'm sharing those tips with you. That basically just I'm using this little hookup wire when I want to program it, connecting between ground and pins G0, and that makes it really easy. We'll do that again in a second when we actually upload something to here. I thought I would do a couple of examples. So right now I've got this mic test sketch loaded up. The thing with this, though, is that the screen is very bright. I haven't figured out how to turn the brightness down yet. I don't have a great camera, so it's not a good example because it just completely washes out the screen here. So instead, we're going to look at the text test, and then we're going to look at a cellular automata example. All of these are in the M5Stick-C library, the Arduino library that we loaded up a minute ago. And yeah, so I'm going to pull up Arduino. I'm not going to share this screen with you, but you can find these exact sketches on their GitHub under examples. And then I think all the display ones are under advanced. So I'm going to be looking at cellular automata and the print test, which I have open here. There's a spirograph, it looks like. There's a Starfield one. All kinds of cool. I want to see what the terminal one is. There's a clock you can wear. Is it a watch? Very cool. There's a QR code option. Oh, and then I've got this basics, the microphone. It says it should be microphone, obviously, but it works. And then look, they've got games and things. So for now, I'm going to start with the text TFT print test sketch. So I've set the upload speed to 115/200. Which was one of the tips from the M5Stack employee who was posting to the forum. And I've found which port it's on in Arduino, so I'm going to upload. Oh, and since I've hit upload, I'm going to go ahead and connect ground to G0. It's going to compile for a while. And it's uploading. It says connecting, and now it's writing. And it's 11%. I should learn a beatbox. Done uploading. Okay, cool. Now it says that it's hard resetting via the reset pin, but I don't believe that. I think that it is still doing the mic test, and I need to hit the little power button here and hold it for 6 seconds so that the thing turns off. And then I'm going to turn it on again, and we should have a little print test. Hello, we have 2 Davids saying hello in the chat. Hello, both Davids. If we have any more Davids, hello to you as well. So many Davids. Oh, I should probably unplug that so it's not in programming mode. Hello? Ooh. I wonder if I messed it up somehow by, Nope, it just straight up doesn't like me right now. I've been playing with this all day, and of course, in time for the live demo. It wouldn't be a live demo if there weren't a problem. But fortunately for you, actually, and for me, I've already got a video I took of this, so it's right in the tutorial. Let's take a look. And then in a minute, we'll try again. So you can see that it basically just shows like hello world and a little textual display and some other cool stuff. Did you overheat? What's your problem? Nope. It's just being a jerk face. All right. Oh, hey, there we go. Okay, cool. So now maybe you can see it says, oh boy. Hello world. It says group I implore thee, which I assume is some kind of a reference to a text adventure game or something. If you recognize that reference, GROOP, I implore thee. I could Google it, but that wouldn't be very fun, would it? Nah. So that works. Cool. I'm going to try one more because I want to look at this cellular automata one. So John Conway, creator of Conway's Game of Life, hated that Conway's Game of Life cellular automata system was what he was most known for, but we're going to talk about it again anyway. He recently died, and it was like everywhere and very sad. But let's take a look at what cellular automata are. A discrete model studied in computer science, mathematics, physics, complexity, etc. A regular grid of cells, each one in one of a finite number of states, aka like on or off, or like if you had an RGB color space, it could be anywhere from 0 to 255, or like, and those can represent anything else as well. You could have a hexadecimal value of things. Anyway, so each cell is in a finite number, one of a finite number of states, such as on and off. The grid can be in any finite number of dimensions. So it could be 2D, like the one on the right there. It could be 3D. It could be 1D, just a line. It could be a single pixel, and all you'd have is like on or off data. Carlos also says hello. Oh, cool. We've got people from all over. Hello, everyone. So let's see. Yeah, and so then you have rules basically that determine what each cell is like based on the cells around it. And on the right here, we have an example of a glider gun, which is something that someone else called Gosper created for the Conway's Game of Life system of cellular automata. Okay, so that's what that is. And what I'm going to do now is load up the Arduino sketch in the examples for this guy that is called cellular automata, and I'm going to see what it does. Yeah. This is an experiment. I haven't seen what it does yet. The cool thing about the microphone test sketch is that you can see a sort of compiled wave of what the sounds look like. So if I sing a pure tone into this thing, it actually seems to produce a graphical representation of what that wave looks like. And based on how musical tones are mathematically based on frequencies, if I hum a tone that's 1 octave higher, you should see a wave that's twice as fast or has half the wavelength. And that seems to be consistent with what I see when I hum into this thing. So that's pretty cool. Okay, so now we're uploading, done uploading. It always says it's going to reset. It never actually does. Let's turn this off and on again. Off. We have a comment that says it's the same ESP82-based that has a small screen. Interesting. Oh, here we go. Arduino cellular automata, it says. Oh, cool. So my guess is that each time it produces a semi-random seed. And so the seed is sort of like the seed is sort of the initial state of the automaton. And this is so cute. Oh man, imagine, well, that'd be really hard. But imagine if like every second you had this go, and then in between you displayed the time, or like every 5 or 10 seconds it did this, and in between it displayed the time. That'd be so nerd fashion. Yeah, what a cool thing. Anyway, so that's very exciting. I love the demos they have for this. It's extremely easy to program once you get the hang of it and get past those first couple of error messages and stuff. And I had a lot of fun with it, and I'm looking forward to doing more with it. For now, let's have a look at the pulse sensor I'm using. So this is what I'm trying to hook it up with. I realized belatedly that this is looking for an analog input pin, and there don't seem to be any of those broken out externally on the M5Stick-C, so I'm going to have to figure out how to make that work. They actually have their own Arduino library that makes it really easy to get the beats per minute of your heart. Someone has written an integration for the M5Stack for this sensor, which the M5Stack is a cousin of the M5Stick. They're both by the company M5Stack. You can find them on Hackster, of course, Hackster.io/M5Stack. And you can see their different products under here. So here's the ESP32-based M5Stack Core IoT Development Kit. There's the M5Stick-C mini dev board, which is what we're looking at now. There's also a little camera based on the K210 that has AI. There's a little, all these different accessories and things for it, breakouts for, like, for example, a moisture sensor, all this cool stuff. We also talked about the M5 Faces pocket computer, also from our friend Mohib, who supplies us with many cool things. And we try to return the favor. And by we, I mean I. So, okay. Yeah, this is the M5Stack. Someone has already written integration for the pulse sensor for that. So I'm assuming that, although the screen dimensions are different, it shouldn't be too hard to adapt that code for this device. Also, there's a really interesting other project I found where someone is trying to create a high-speed analog scope for ECG, or electrocardiograms, which is also your heart activity. And they're trying to input an analog sensor for that into the device, and they broke it open. They're sort of doing a public service here. They say that M5Stack haven't published any photos on the internals, etc., which is annoying, and no one else seems to have either. So you can look in here, and they give you extra tips on how to take it apart. That includes cutting away a little piece of the case in order to not kill the headers that are part of here. So you can also just take a look at theirs. And this person is the one who noticed that there's a magnet inside, so maybe you can stick it to a fridge or whatever. I'm excited to try that. It could be kind of cool to use the motion sensors, for example, to see how often I open the fridge, or people in general open the fridge every day. Maybe how that correlates to our energy usage. Who knows? I could make this into a little wearable. Without any physical modifications at all, I could easily turn this into a little wearable sensor for gestures. I could use the microphone to make another version of my touchless hand washing timer and nightlight thing that we did with the Circuit Playground Express, so that it'll count you down 20 seconds when you make a loud noise, so that you can make sure that you're washing your hands properly. Any number of things are already possible with the kit as is, but I'm also excited to explore these other... I might not have been showing you my screen when I was looking at this other thing on GitHub by Inertia, which is the ECG tracker with the pictures of the internals of the device. So here those are now. You can see a little GIF of it working to sense heartbeats. That's so cool. The sampling rate seems to be really high, which is cool. And that's probably why I could get such a nice view of the audio as well. Look at these, such nice pictures. Good lighting. Nice focus. Look at that, so sharp. Oh, that's interesting. It says M5Stuck-I on it, or 1. I wonder if that was the original name because it had a magnet on it. No, probably not. Anyway, so yeah, if you're curious about this, go check out the M5Stack portal on Hackster at Hackster.io/M5Stack. You can find this M5Stick-C device on here, including my new little getting started, which I think I published after the last time I loaded this page. Oh no. Well, anyway, all kinds of stuff like real-time data monitor, wireless barcode scanner using that little AI camera thing, Libra watch and wallet for I think it's oh my goodness, what do you call them? Blockchain coins. Mine is drawing a blank right now. But anyway, you can display that on your watch. Hall sensor and temperature sensor, an ESP32. Wow, look at that. You can graph all kinds of stuff. I just love that it has this little screen on it, and it's so useful right out of the box. So, thanks for joining. That's our first adventure with the M5Stick-C device based on the ESP32. Check out the links, as always, in the description to the video for all the things we looked at today. And hope to see what you build with it. And stay tuned for more of this stuff from me. Here's a sneak peek of the microbit running with the pulse sensor. I haven't gotten that quite up and running yet because for some reason it doesn't want to detect my pulse. Maybe I don't have one, but this is the example sketch put out by the pulse sensor people. And you know, here it's supposed to be sort of oscillating according to my heartbeats, but it doesn't. Even if I block out the light, it doesn't. I don't know why. We'll figure it out, and that'll be another tutorial for another day. In the meantime, enjoy what you're up to, stay safe, and hack on.